Alright, hi students, this is Dr. Thomas again. In this video I want to show you how to rationalize denominators with radicals. So if you have a radical in the denominator, then that's a problem, because in math we just have to get it out. We got to get that radical out of the denominator. Alright, it says a fraction that contains a radical in its denominator can be written as an equivalent fraction with a rational denominator, a denominator without a radical. It says never leave a radical in the denominator of a fraction. Always rationalize the denominator. So on this website is regentsprep.org. I found this website on the internet, so you can do the same thing. If you need to figure something out in math, you can always Google it, Bing it, whatever. Just search for it on the internet, and sometimes you can find some great resources. So here, let's look at the first example here. The first example is 2 divided by the square root of 7. So as you can see here, square root of 7 cannot be simplified any further, but there is an issue that the radical is in the denominator. So what do? They multiply the top and bottom by the square root of 7, because square root of 7 times the square root of 7 is the square root of 49, which is what? 7. So if you multiply the numerator and denominator by the square root of 7, and the reason why that was done is because 7 times 7 is a perfect square. So we want to multiply that number here times another number that will give us the lowest perfect square. So 7 times 7 will give us a perfect square. So as you can see in the next line here, you have 2 times the square root of 7, because we're just multiplying the two numerators together, and the square root of 7 times the square root of 7 is square root of 49, which is 7. Voila, the radical is now out of the denominator. Let's try another example. Alright, this little star says sometimes it is necessary to multiply by whatever makes the denominator a perfect square or perfect cube or any other power that can be simplified, as seen in the next example. So we have 5 divided by the square root of 8. Now, most students say, oh, just multiply by the square root of 8, and that's okay. But notice that if you just multiply times the square root of 2, then you also get a perfect square. You get the lowest perfect square, which is actually better, so we don't have to simplify as much. So we have square root of 8 times the square root of 2, which gives us the square root of 16, which gives us 4. Voila. The radical is out of the denominator. Exactly what we wanted. Example 3. Simplify 4 divided by the cube root of 9. Now we got to switch our thinking to perfect cubes. 9 times what number will give us a perfect cube? Turns out we can use 3, because 9 times 3 is 27, and the cube root of 27 is 3. Voila. The radical is out of the denominator. Alright, let's try an example where you have a binomial in the denominator, where it's a radical, but it's also 2 terms in the denominator, like so. 2 divided by 5 plus the square root of 3. This is a little different because it's more than one term in the denominator, and we normally multiply numerator and denominator by the conjugate of the denominator. What is the conjugate of 5 plus the square root of 3? It's 5 minus the square root of 3. So the only thing that changed to get the conjugate was to change the sign in the middle to the opposite sign. And once you do that, if you multiply conjugates together, they're binomial, so we have to FOIL this. So 5 times 5 is 25. 5 times the negative square root of 3 is negative 5 times the square root of 3. Positive 5 times the square root of 3 is plus 5 times the square root of 3. And square root of 3 times the negative square root of 3 is negative square root of 9. Notice that the middle terms here will cancel out. That negative 5 square root of 3 plus 5 square root of 3 will cancel out. And you have 25 minus 3 because the square root of 9 is 3. 25 minus 3 is 22. Voila. The radical is out of the denominator. The only other thing is here in the numerator we're saying 2 times 5 minus the square root of 3 because those were your two numerators. Don't ever multiply the 2 through, because at the very end notice that you can simplify a little further. That 2 over 22 can be reduced, and you would not have seen that as quickly if you had distributed the 2 into the 5 and the square root of 3. So the final answer does not contain a radical in the denominator, and that's what we wanted. Let's try one more. Example 5 here. Simplify 2 plus the square root of 5 divided by 4 minus the square root of 5. Again, this is a binomial in the denominator, so we will multiply the denominator by its conjugate. We're not concerned about the numerator having radicals. We're only concerned about the denominators having radicals. So what is the conjugate of 4 minus the square root of 5? It is 4 plus the square root of 5. So we multiply numerator and denominator by 4 plus the square root of 5. Alright, so when we do that, notice always when you multiply conjugates together in the denominator, the middle terms will cancel. And as you can see, you end up in the denominator having 16 minus 5. 16 minus 5, and you'll have 11 in the denominator. Alright. And that's all I wanted to show you for this video. I just wanted to show you a quick video on how to rationalize the denominator. And you can find this website at www.regentsprep.org. You can just copy this website up here. If you want to type that in your search engine if you want to see that particular resource. Alright, I hope this helps.